Chapter 16 Loops. Loop statements allow you to easily repeat a chunk of code many times. For example, in a game with a bouncing ball, it would be too much work to type out the code to make the ball bounce up and down 1,000 times, move up, then fall down, move up, then fall down, move up, then fall down. Instead, you can put the repeated code in a loop. Repeat 1,000 times, move up, then fall down. Loop is not only save programmers time, only also make programs shorter, which makes them easier for the computer to learn. When creating a loop, you should answer the question, what do I want to repeat? When I want the loop to stop repeating, there are different types of loops. For loop is a type of loop that repeats itself a set number of times. For loops are used when you know the number of times you want to repeat something. For loops and arrays are often used together. For example, you could use a for loop to list all the top 10 players of a game whose names are stored in an array. Top 10. Player 1, player 2, player 3, player 4, player 5, player 6, player 7, player 9, player 10, an array containing the names of the top 10 players. For item in top 10, beginning for loop, repeat the code in the loop for each time in the top 10 list. Print item. The code that's repeated, print out each name in the top 10 list. A while loop will run a chunk of code until a condition is met. This is used when you don't know the exact number of times when you want the loop to repeat, and it depends on another factor. For example, in a quiz game you can repeatedly ask a question until the user gets the correct answer. While answer is not correct, ask the user, what's the name of the current Vice President of the United States? Print you are right. The quiz game would continue to ask the question until the user got the right answer, even if it took 100 attempts. Nested loop is when the loop is put inside another loop. Nested loop helps create a more complex repeating code. For example, you could program background music for a game using nested loops. A nested loop can repeat a beat until the game is over. An inner loop can repeat a bass drum sound 7 times before a snare sound is played. Repeat 7 times, play a bass drum sound in a loop. Repeat until the game is over. Play snare sound, out of loop. In pseudocode, use identifying the shellcode that is inside or dependent on other side. Be careful when using nested loop because it's easy to get confused about which chunks of code should be repeated. In a loop, always has to run through all its sequences before the outer loop code is run again. For example, the background music would sound like this. Bass drum, bass drum, bass drum, bass drum, bass drum, bass drum. In a loop, snare. Bass drum, bass drum, bass, bass, bass drum, snare, bass drum, bass drum, bass drum, bass drum, snare, out loop. The bass sound is played 7 times, running through all versions is loop before moving on the next line of code, playing the snare sound. Then the entire outer loop is repeated until the game is over. Chapter 17 Events. Events are actions that cause something to happen within a program. They make the program interactive because the user is in control. For example, click a mouse, press a key, tapping a touch screen. Event can also be things that happen within a program, like when a character dies, when the message "Game Over" appears. Event can be external action from a user, like a mouse click. They can also be internal action that happen within a program, like a web browser completely reloading a web page. An event handler is the code that is run when an event happens. Pressing the space bar in a game is an event, but an event handler is the code in the game that tells a character to jump when the space bar is pressed. For example, in a fruit chopping game, you could add code like the pseudo code below the swing the chop's knife every time the spacebar is pressed. On press spacebar, swing chop's knife. Chapter 18 Procedures. Reusing code. The procedure is a piece of the code that you can easily use over and over. Loops are great when you want to repeat an action multiple times in a row, but when you want to use the same chunk of code in different parts of the program, you will need a procedure. For example, in a four-person game, you could program each character individually to jump when each player presses their jump button. But a better way is to create a single jump procedure for each character to use when each player presses their jump button. Procedure, a piece of code that has a name and completes a specific task. Declaring a procedure. Instead of copying and pasting the same chunk of code throughout a programmer can save that chunk of code and name it. When the name of the code, the procedure is used in a program, the computer understands that it should use the chunk of code. To create a procedure, you must declare it by giving it a name and editing the code you want to use as a procedure. It's like declaring a variable and you give a variable a name and a value. You could declare a jump procedure for the four-person game by calling it jump and adding the code that makes a character jump. A function is also a chunk of code, which function performs a specific task like print. Function jump, demo procedure, move, pulse, move back down to the ground, code for the procedure. Step 1. Identify the chunk of code to be saved. Move up, pause, move back down to ground. Step 2. Name the chunk of code and save. Jump, move up, jump up equal, move up, pulse, move back down to ground. Calling a procedure. Declaring a procedure just give it a name. It won't run the code. The procedure will not do anything if you don't tell it to. When you are ready to use the procedure in your program, you have to call it. Call and use the name of the procedure in a program so that it can run the code. For example, the procedure can be called as many times as you want. When player 1 hit the spacebar, jump, name of procedure. When player 2 hit the up arrow, jump. When the player 3 hit the W key, jump. When the player 4 hit the I key, jump. The same procedure jump is called when four different events happen. When the computer reads jump, it will look up the jump function and run the code function there. Parameters and returns. Parameters are available whose value is passed into a procedure. It can give limits or range to the procedure, like jump 3 times. The only difference between a parameter and a variable is that parameter value can only be used in a procedure, but the variable can be used throughout the entire program. The parameter's input can change how a function acts. For example, in space battle games, you can use a function to animate the laser shooting out of the spaceship's gun. Because you want the laser to shoot at whatever the user is aiming at and not the same spot every time, you need to input to the laser function the location that the user is aiming at. The laser function can then change where it shoot each time the user fires the spaceship's gun. X and A parameters can give the X and Y coordinates to the function so the laser shoot in the direction the player is aiming. Function shoot laser XY display laser graphic text to spaceship's gun, while on the screen move toward X, Y. Some procedures or functions can return a value. The return value is the procedure output. Depending on the procedure, you could get a different return value every time you ran it. Parameters and return values are often used in the same function. For example, if you move a procedure that calculates the average reaction speed of the game player, the parameter should be the reaction times of the player, and the return value would be the average of all the players' time. Function average time, player times array, average equals sum all time in play times array divided by number of items in array. This is the task. This is how the task is accomplished. Return average. This is the result of the task. After calling the function average time, the function would return to value that is the player's average time.